There have been considerable research breakthroughs examining both the genetics of schizophrenia and its underlying brain circuitry. Greenman and colleagues bring these two sets of findings together by examining both perturbations in brain function and their relationship with underlying genetic risk for schizophrenia. The findings rely on the well-established working memory paradigm, but use particularly innovative new analytic tools that examine the connections between function in the prefrontal cortex and the parietal lobe. And the new findings suggest both that there are perturbations associated with schizophrenia in the functional connections between the prefrontal cortex and the parietal lobe, but also associations with underlying genetic risk. And this provides insights both for clinicians and scientists who are trying to think about the relationship between the symptoms of schizophrenia, its underlying risk factors, and perturbations in the neurological architecture. Many studies have used brain imaging to examine structure in psychotic disorders. Huang and colleagues examine the relationship between schizophrenia and risk for schizophrenia with volume of the thalamus. Now, considerable research implicates perturbations in the volume of the thalamus in schizophrenia. The new findings to emerge from this important paper are to examine subnuclei of the thalamus. And the paper generates interest both in the dorsal medial nucleus of the thalamus, which is a portion of the thalamus related to the prefrontal cortex, and the pulvinar, which is a portion of the thalamus that might be particularly important in primates. The findings not only relate volumes of these structures to the diagnosis of schizophrenia, but also to its underlying risk as manifests in young people who are showing early signs of risk for schizophrenia. As a result, the paper is of interest both to clinicians and neuroanatomists.